So this is the second session, doubt clearing session, and here we are discussing some problems based on the second week, whatever the content professor taught here. In the second week, we'll discuss some problems and we'll take some doubt from students to that we'll discuss in this here in this session. Right? I'll just arrange this one. So this is the second session. Mm, in first session, first week, we have discussed all the introduction to the stereochemistry and the some structure of the some basic compound organic compounds and the why the stereochemistry is important in case of the organic chemistry, right? All this we have covered in the first session, and in the second in sorry also we have covered this different symmetry elements like identity, uh, symmetry uh, symmetry elements like identity, C and axis. I'll just review this one once. Like a symmetry operation, like identity operation. Cn, which refer to the n-fold axis of symmetry. Sigma is the plane of symmetry and center of inversion as well as the n-fold uh, rotation, right? And these different with the help of different diagram, we have also studied or and discussed in the first video, like how this operation are getting performed on the simple structures and all. Also covered the molecule as shown here. We have discussed in the first week all this how this S6 axis is present in this molecule, and many other examples also we have studied, like here center of inversion in the cube system, uh, how the C2 axis is present in the methane molecule. These all things we have covered in the first session. And different point groups. These different point groups are also covered, right? How this the point group present in the molecule, and molecule belong to which point group. That problem we have covered in the first session. These are the problems already covered in the first session. Methanol belongs to which point group? So methanol belongs to CS point group. These all things we have already discussed in this in the first session. And now we are taking some advanced problem that we are going to discuss in the this week. This problem will belong to the second week. All the topics that are covered by the Professor Amit Basak in the first week. That problem we are going to discuss in this one. So here, uh, the for today's the first problem is the consider the following molecule and identify the correct statement among this one. So here there are different statements they have given. Uh, Here firstly they have given the molecule has the sigma and CS, sorry S1. Molecule have a sigma and S2. The molecule has C2 and S4, and the molecule have the C2 and molecule has the C2 axis. This problem we have visualized with the help of these explanations as shown here in the last. But uh, some of the students commented on this. They not able to understand how this one will be the product. This one will be the correct answer. How this they are some not able to visualize the C2 in this molecule and the S4 also in this molecule. So we'll discuss it one by one again. So let's take this one. How this it has the C2 axis present. So in this one, see, this one is the molecule, right? And it has one hydrogen and a center which having the a chiral center which having the configuration S configuration, right? And here A group which having the chiral, configuration R. Here also A group which having R configuration, and downward there hydrogen. Here also hydrogen, hydrogen, and A group with the S configuration. See, we need to just we can see we can easily see the axis which passes through this center. I will just hide this one for understanding. See, here is the one center, right? So the axis which passes through this center, we need to pass the axis through the center, and here we can able to see if we rotate this molecule by 180 degrees Celsius, what it refers to? It refers to the C2 axis, right? So after rotating this molecule by 180 degrees Celsius, this AS will go to the position of the second one. So the uh, so this AS, suppose I noted it by the pink color, and this one is with blue color. This pink color one goes in the position of the second one. So this center will remain unchanged. This group remain unchanged because these are the both are the equal groups, right? The AS and the AS will be equal. Similarly, all other groups are there. If you see here, AR is present. This AR comes to this the position. The second hydrogen is replaced by this hydrogen. So it has the C2 axis. So most of students confirm they are able to visualize the C2 axis, but they are not able to visualize the S4 one. So that problem will check again. In this one, we need to note two important things, right? Concepts. First one is the configuration of chiral center remains same after rotation, right? Suppose we'll just take one group at a time, like here AS and here AS. See, this having a S configuration, this group having a S configuration. After rotation, that is by C2 degree, the configuration remains same, right? So it is rotation doesn't affect the configuration of the center. So if you do the rotation, then also the configuration of this center, when it go to after rotation, it will go here. It will remain same. So it doesn't get changed. But after rotation, but after reflection, it get changed. That is, if it is R configuration initially, but by doing the reflection that is sigma, it will be converted into the S configuration. This point we need to note. So how the problem will we can visualize then here we can see the S4 operation is performed. What is meant by S4? S4 is referred to the we need to do a C4 and then we need to do the sigma plane, like which is perpendicular to this axis, this rotation axis. So after doing the C4 axis rotation, C4 means we need to rotate molecule by the 90-degree, right? Uh, since it's a C4, that is 4, that is therefore 360 divided by 4, which refers to the 90-degree, right? The simple one. So we need to just rotate the molecule by the 90-degree, and we can able to see the hydrogen here. After rotation it by 90-degree, it will go here. This is here labeled also. The 2 number carbon atom goes to here. So we did rotation in this direction, suppose. So these two number hydrogen go there at this position, right? Similarly, the AS, the group we attach to the carbon, right? Say which same carbon will go here. We will focus on only few groups, right? It will go at this position, and similarly, other group are also shift accordingly, right? By the rotation of the C4 degree C4. First we did the C4 rotation, and then we need to take a mirror plane. In this mirror, when you take the mirror plane, we need to pass a mirror plane which is perpendicular this to this axis. So the axis of rotation in this direction, right? So mirror plane will be the perpendicular to this, right? Let's make some place to, right? We have noted that is after rotation, we are not able to, you should not change the rotation axis because it is rotation invariant. Means if you do any axis of rotation, the configuration remains same. So here S remain S. Note this S remain S. Similarly for all other center, here AR, when it after 90-degree rotation, it goes the position this, that is it come here, and the R remain R, right? Similarly all other centers are also getting interchange, but the configuration remains same. And here we can see, now we need to pass a perpendicular mirror plane. So what happened if you pass this plane through this molecule? Uh, let's consider this molecule like this, right? Like these groups are present, and we need to pass this mirror plane through a plane of this molecule, right? So what happened? The upper group comes to down. When these groups are, this upper group goes to down and lower group goes to upper side, right? So after reflection, when you pass a mirror plane from this one, so after reflection perpendicular through this axis, what happen after sigma h sigma, then it will be like this, right? So in this diagrammatical diagram, in this diagram, we can able to uh, see the groups get interchanged from initially the dark one in the lower side. Now they are the in upper side. Similarly, here also happen. This initially here is the A group and lower is the hydrogen. Now this group goes to the down and hydrogen will remain goes to up, right? But here we need to note these things. Since we have passed a mirror plane, the configuration get opposite, right? Initially it is a R configuration, now it is the S configuration. Uh, so all groups are getting, here initially it is R, now it's S. Similarly, here it's S configuration, right? So it will go upper side, but with the it has the now R configuration. So this is the reason why you are not able to understand uh, how it get it has the S4 axis, because this groups configuration of this molecule getting changed due to the sigma plane. So this was the problem. So hope we are able to understand now why it has the S4 axis also. So the correct answer is this. Correct answer is C2. That is, it has the C2 and S4. So this hope now it's get clear. Now this question, we'll take up another problem now. Here they have given identify the point group to which the following molecule A and B belongs. These molecules are given, and we need to identify the point group, right? So these molecules they have shown in the planar molecule, but not it's not a this is a 2D diagram. So we need to draw this into the board form, right? So for that purpose, we'll draw first this molecule, the first one, and in this one we can consider we can see this black dot which refer to the hydrogen attached of this position are at the upper side, right? So the hydrogen, so we'll to draw the simply diagram we'll give A B C ring, right? And here this one is the middle ring. Why this one? Always try to draw a middle ring first and the then the lower rings, because we can able to easily draw another sorry remaining rings if we draw like this in this way, right? And then we'll draw a ring. You can see here this hydrogen are upside, so the hydrogen here is upper, this hydrogen also up. Now we'll draw a B ring, sorry A ring, in which by default now the hydrogen need to lower, here also carbon lower, and now remaining carbon we need to arrange so as this will be look like a boat. So this pink one is the boat, uh, A ring. And now we need to draw the C ring. How the C ring will be? We will draw with some different colors so I am able to visualize this. The C ring. Here they have given not show any dot, means this hydrogen should be the lower side. So here also this hydrogen should be lower, right? And this hydrogen should be a lower. Now remaining carbon of this ring we need to draw. So by default, the next carbon will be up. Here also next carbon will be up, and we are going to. Oh, sorry. When we are drawing, the boat should be looks like a boat. It should not look like a like different shape. So we'll try to then only we can able to visualize the which symmetry element is present in this molecule or something, right? So here we can see now these are this one. So the C ring will be represented by a black colored. This B ring is represented by the blue one, B, and A ring which is represented by the pink one, right? Hope you are now able to visualize. So in this one, just forget about the previous any answers. Whatever they written here, they may be correct or not. We need to now visualize this molecule. A molecule belong to which point group, right? For this purpose, uh, here we have drawn this one. Is anybody having question? Let me check just comment session. So there are no comments in the comment section, so we can continue, right? So here we have draw the A molecule in this form. So now we can able to visualize which point group it belongs to. This molecule belongs to. So you can see there are different hydrogens or atoms are also attached here in this one. Let's see at the center point. So what you can see when you go in the opposite direction, here there is one ring carbon atom, and in this direction also there is one carbon atom, and similarly all other things are also there. I mean, uh, the similar direction here also they had the CH2, here also the CH2. The all other carbon atoms are exactly opposite to each other. See, you can visualize all these centers. So they are exactly opposite to each other, right? So it has the center of inversion. Any plane, if you are able to visualize, see, here there is no any plane. First we need to see, is there any uh, Cn is present or not. So if you do the two, if we pass any axis from any direction, so we are not able to visualize any, is there any axis present here. So it doesn't have the any Cn axis. Secondly, need to find out any plane sigma. Either is there any sigma? See, this plane is not, this is, it doesn't have any plane. If you pass the plane like this, which is passes to the plane of this thing, but they are not exactly right matches. After taking a mirror plane, this ring will be go in this side, and this ring will go at this position. So these are not a mirror plane. So it doesn't have the any mirror plane also. So it doesn't have any sigma no. Then we can focus there is no Cn, there is no sigma. We need to check inversion center is there or not. So we have already found out it has the inversion center. All the points are exactly uh, opposite groups are present from this center. So see, any point we consider, let's say this hydrogen, let's say uh, this hydrogen, where is this, its opposite hydrogen will be here, its opposite hydrogen will be at this position. See, similarly this hydrogen is present upward, so similarly in opposite direction here also there is one hydrogen. So it has the center of inversion center, right? And no all other no any other element of symmetry. So where the point group will belongs to, as we have already a chart. What, where is the chart? Sorry, I have placed this here. So see, when the molecule is linear, it's it's not a linear molecule. Does it have any axis present? So it has no any axis present. Does it have the any Cn axis? It has already seen it has no Cn axis. Having any mirror plane? No, it doesn't have mirror plane, so we'll need to go this direction. Does it have the center of inversion? So yes, it has the center of inversion. So this molecule belong to Cn point group. So this one will be the root. This chart we need to consider always. So we can able to easily figure out this molecule belong to which point group. So we'll just take this near to our problem. Hmm. So By going through this pie chart, we can able to easily identify this molecule where it belongs to. So it has the center of inversion only. So this molecule belongs to Ci point group. Similarly, this second one, this one we need to check now, right? So how we can check? Uh, we'll just add one slide so as we can discuss on that slide. So this one is the molecule. I'll just copy paste it there, just there. Right. The first molecule we have seen it. First molecule, this molecule we have seen it belong to Ci point group. Right. Now it's time to check the second molecule. This molecule. This molecule belong to which point group? So here we can see. First, we need to draw this molecule in the board form. As usual, this A ring, the B ring, and the C ring. We will draw the middle ring first. So middle ring always draw like our regular chair. What we are generally drawing, which in which you are comfortable. See, sorry, the chair should be looks like a chair. So then and then only we can able to visualize uh, whether this molecule belong to which point group. So we can clearly able to understand if we draw a structure properly, right? So these are the in the plane, these are the plane, right? Now here the E, what they have given, it's the dot bold atom. Where it is, it's
Hydrogen.
here hydrogen it's upside, so we need to draw the hydrogen which is upper side, and here we can see the hydrogen is lower side because it is not given the dark one, means the hydrogen obviously by default belongs to lower side. Now we will draw the C ring one, the C ring one here. The remaining carbon, additional carbon, we need to arrange first, and remaining chair then we can draw. So this one would be the remaining carbon of the next chair. Now uh, this one is the C ring, this one is the D ring, right? Now we will draw the A ring. How here we can see the hydrogen is upper one, upside. So this hydrogen it should draw upper side, and this hydrogen also the upper side. So this hydrogen also in the upside. Now we need to arrange remaining carbon atom. So here this will be in this direction, right? Uh, Here it will be in this direction. So this after drawing the additional carbon, remaining carbon we need to draw accordingly so as it will become a chair like a structure. So we'll just rub this carbon hydrogen atom, sorry. So you can see these are the, it should look like a chair, right? Here hydrogen atom and here on the hydrogen atom. Now in this one we need to check which point group this molecule belongs to, right? So uh, from initially we will follow directly our pie chart. In this one I will just rub all this thing. So we will start from beginning. So here is this molecule. Does it molecule, is this molecule linear or non-linear? So obviously it's a non-linear one, right? Here is the molecule and this one is the non. I will just take this molecule on that page so as we can able to visualize it. Actually, I'm not that much comfortable with this. Sorry. I'll just paste this molecule here so as we can able to, and I'll also take this pie chart here. I'll send to back. Huh. Right. Now we can able to visualize this one. So see the molecule structure we have drawn in the chair forms. Now we need to start this one, and here we can see it's a non-linear molecule. The molecule is linear? No, it's a non-linear one. So we need to go with this option. It's a non-linear one, right? Then does it have the two or more CN axis?
It's one series.
Right. It doesn't have any CN axis. Sorry, C. It doesn't have any kind of CN axis, right? Because if we pass this molecule, see this one is the ring. These two rings are in the plane, but if you see this ring, it's bended downward, so it doesn't have any CN axis. You can able to visualize here. If you pass any C2 from this one, this direction, sorry, any axis from this direction, it doesn't have any axis. So this one is the wrong one. This one is the correct. So we need to go this direction. Does it have any CN axis? Having any axis, we have already seen it doesn't have any axis. So we need to go this direction. Now we need to check, does it have any mirror plane? See, if you pass a plane through this same the plane of this where this four carbon atom belongs to, right? Then you can able to see it doesn't have any plane from if you pass this sorry, plane to plane through this one. It doesn't have any plane like this one. If you pass a vertical plane, see which passes through this carbon atom, but you can see it doesn't have plane here also. You pass to the plane through this hydrogen, sorry, through a bond to this one and this one. So we need to pass this one through and the plane which is passes through these two. But we can see this back side and here the front side. They are not they are not symmetrical, right? This hydrogen is upper one, this hydrogen is a lower one, and it doesn't have any kind of plane in short. So so it doesn't have any kind of plane also. So this one is wrong. We will not go that direction. So we need to go here. Now we need to check center of inversion. See, does it? We need to check, does it have any center of inversion? Initially, we will check only for simplicity only the center carbon chain. and then we will check remaining hydrogen. See, the center, where will be the center? Here will be the center of this molecule. But if you see this one, this one is the opposite one, opposite center. But if you go to another direction, it doesn't have any kind of the any kind of atom which is opposite to this one. If the ring will be in this way, if ring will be like this, then may it, as draw here red, then there will be possibility of this center of inversion. But the original ring, the structure is like this one. So these are it is this one is the ring opposite to this ring, but it's not like it doesn't have the say opposite center with the equidistance, right? Opposite side. So this one will be, should be the center to which opposite to the a center, but it is not present in this molecule. So this one, so it doesn't have this. In short, it doesn't have the center of inversion. So another option now, where it belong to? Does it have any center of inversion? No, it doesn't have any center of inversion. So this molecule will be the C1. Molecule belong to point group C1. C1 point group. This molecule belong to C1 point group. So just keep in mind this pie chart. So with the help of this pie chart, we can able to identify the molecule belong to which point group. So we need to we need to understand these pie chart, so we can able to get the point group which molecule belongs to. So we'll take next examples. So the correct answer, we'll just pick correct check here. Yeah, this molecule belong to the first molecule belong to the C1 point group, and the second molecule belong to the C1 point group, since it doesn't have any kind of symmetry element. But it has, sorry, only the identity is the present, so it molecule belong to the C1 point group. This question already we have seen in the last one. Here, I just want to add one point. If if any of the conformation is achiral, if any of the possible conformation is achiral, then the molecule will be the entirely molecule will be the optically inactive one. So for this one is the correct answer, since it has the here achiral center, it having the all achiral they have given in this one also achiral given. So what they have they told, uh, we need to consider all this one, and at the ambient temperature they are in the equilibrium. So which is the correct statement? So A, B, C, D all are chiral compound. This is a wrong statement, since it have the this achiral molecule the conversion. Only this B compound, we can say it's a chiral one, since it doesn't have any achiral conformation in equilibrium. Here also achiral conformation are there. In the case of D molecule also achiral conformation is possible. So it's a wrong statement. Since A has more chiral conformation than D, so the specific rotation of A should be greater than D. No, there is no any such relation with these, like a specific rotation and when the conformation is present or not. If it having the any kind of achiral, then all the molecule will be the optically inactive molecule. And so no, the specific rotation, when it will become in picture, when it is optically active compound, then only this uh, this comes in the picture the specific rotation. A, C, D all are achiral molecules. So This one A, C, and D, right? This A, C, T, all are the achiral compound. So this one is the correct answer. And where it seems C is achiral one. Yeah, C is achiral one, right? This one is also a correct statement, achiral one. But consider the three compound ABCD given below. The conformation equilibrium under ambient temperature for each of the compound and individual chirality of this conformation. C. C is only, they have written only. So because of this statement is wrong. It should not be only. C is ichiral, but it's not only. Since they have written the only, so this one is the wrong statement. So these small things we need to notice what they have written only. It's not only, right? Because this is also the achiral one and D also the achiral one. Yeah, C is achiral one is correct, but D and A also achiral. So these small things also we need to keep in mind. Arlin system also we have discussed in detail in the last lecture. So we will not go in detail in this time. So this was the question. These are the comment. Somebody inform me how this Arlin system it having the axis and S4 axis in the Arlin system. This S4 axis in Arlin system that we have discussed in the last session. This YouTube link of this session. Hope you will get. You have received it from a mail from the NPTEL team, right? Please go through that videos also. So if anything not get cover, not able to understand the last session. So this was a comment from the one student. So I have just added in this PPT also. So these are also discussed in the last session. So here in this one, I think no need to utilize more time on this one. Now, see, this one is an interesting question. Uh, what they have written? Consider a molecule P and Q. So they have given the two molecule and identify correct statement. So firstly, whenever you are seeing any question, just we need to observe the molecule first, right? So I'll just make it little large. We need to understand the question first. So for understanding the question, what they have given only the correct statement we need to identify, and these are the structure given. So we should observe these structures. Then and then only we can able to solve this question, right? See what they have given here. The molecule P has S4 and molecule Q has inversion center. So just we'll neglect one options so as we can reduce we can go to the correct option one. Molecule P has S4. So identifying S4 is little complicated. So we will check once firstly this one whether it having the really inversion center or not. This Q molecule having inversion center or not. So check here. This one will be the center of the molecule, and here will be the hydrogen atoms. All right, these hydrogens are opposite to each other. Okay, so no need to check these hydrogens, right? Equidistant opposite molecules are present. Similarly, so it is sorted. The center also sorted. See, it's having the downward directing bond. It having upward directing bond. So right, up to here it's okay. Now we need to move further, right? So this center, we need to check this center and this center now. See, what is the configuration of this center and this center? First, we need to check which groups it's having. It is having chlorine atom. It is also having chlorine atom. It's having the C structure of this cis group, right? Here also there is one cis group also attached, and here a trans group is attached, right? Here also a trans group attached here. So the groups are there, but where is the trick? We need to check the configuration of these groups also. So what is the configuration of this carbon atom? Let's give the numbering. The chlorine will be the first one, the trans and the cis. Since the trans one will be the second one, and the cis one will be the third one, right? So what is the configuration here? 1, 2, 3. It's R, right? But R changed to S since it is a lower one. This one having the S configuration, and lower this group having the chlorine atom. It goes numbering 1. The trans group it group 2, and this one is a 3. Uh, it's having R, which is changed to S. It's also having S configuration. C. It's having the S configuration. Lower group also having the S configuration. That's why it is it should be opposite. Then and then only you can say it's having the inversion center. So this molecule doesn't have the inversion center. So how we can check? We just check how this if the same group are attached and having the same composition, they are having the same composition. So whether it's having the inversion center or not, this we can check by like this. So it's having the yes. It if it is R, then and then we can then only you can say this will be the this will be having the R inversion center. So this molecule doesn't have the inversion center. So this option by default get incorrect, right? Second option is the P molecule has the inversion center, Q molecule has the C2. So this one is the correct wrong answer. The here in the second option what they have given, the P molecule has inversion center. How you can check? We'll we'll keep a imaginary center, right? And check, okay, these are the group having this opposite to each other, so this no need to consider more, right? And in this one, see the lower group at lower attach, this one up attached upper side, and similarly the same group, this the ring is attached, phenyl group is attached, and hydrogen attached. Similarly, this ring is attached here, phenyl group attached here, hydrogen also attached. So all groups are attached. Now where the picture come, we need to consider the configuration, absolute configuration of this molecule, right? So we will give the numbering first. So numbering where it will go. Here you can say the phenyl group attached. Phenyl goes to 1, this second, and the lower ring is the third, right? So what is the configuration of this one? So 1 phenyl 2 3, right? 1 2 3. So it's R change to S configuration. Here don't be confused since it's given like this. The similar center just for understanding purpose I will write the I will write it here, right? This one is the carbon atom, and let's say this one is the phenyl ring. I have kept the compression same, and here is the this cyclobutyl and whatever the group, this chlorine group and this all ring attached here. So these are some tricky questions that we should have a practice to solve this questions like this. And here is the hydrogen attached, right? I have kept all compression as it is. Just I have seen from upper side, upper view, so it will look like this one, and this lower side. See, now we can able to. If here is the phenyl ring, here we will give the numbering. This phenyl ring 1, this one is it 2, and this one is the third. And if you see like from this side, so 1, 2, 3, it's R, it changes to S. So this having the S configuration, right? So this thing we should always keep in mind. So for that purpose, we have to imagine the molecule. So it's upper side, the group having the S compression. Similarly, here also we need to check what is the compression at this position. So what are the numbering? Phenyl 1, the group is 2, and this one is the third. So 1, 2, 3, it's R, which is changes to S1. 1, 2, 3. It's sorry, it's come here also we should not do any mistake, right? While giving numbering. Phenyl group having one compression, one number, the group having 2, and this one having the 3. And we will do the numbering having the R configuration. Right. If you see from this direction, 1, 2, 3, it's having the R configuration. Uh, Similarly, in this case also, we need to consider the molecule. Just I'm just keeping for simplicity. I'm just drawing molecule again. See, many times we got confused in such type of structures. So where this molecule belongs to? So see, let's say these two groups are in the plane, and this phenyl group, which is lower side. So always try to keep this group pH. Now you can understand why I have drawn like this. So give the numbering now. Where will the numbering? Phenyl will be the 1, the group will be the 2, and this group having the 3, right? Now it's check. Let's check. It's having the S configuration, right? 1, 2, 3. It's having S configuration, and since hydrogen is the upper side, so it is having the it shows the R1. So the configuration of this chiral center will be the R. So these two structure always always try to draw the quaternary carbon in this fashion. Then and then only you can able to visualize this, the correct absolute configuration of this one, right? So here also we have drawn like this one. Here also, see, here I have not changed any configuration, any group position. Just I have seen the molecule from different direction, right? Because this phenyl ring is lower side. This we can write here also pH, and we have not changed the position. Just we have seen from the lower sides. Then so as we can able to give the easy, we can able to easily visualize this molecule. So the configuration of this lower side group is the S, upper side group is the lower side group is the R, and upper side group is the S configuration. Since they are opposite to exactly opposite, so it should have the exact opposite configuration. So it has the I also, center of inversion also. So this first statement is the inversion center. It's having inversion center. It's correct. Now we need to check the molecule Q has the C2. So I will just save this slide, and I will upload as the same slide as it is, so as you will get this. I'll paste this question again, the next slide, and what is the option? Molecule Q has C2. So molecule Q has C2 or not? that we need to check. C2. This molecule have it's having the inversion center. So this one is the correct one. But now we need to check here it's having the C2 or not. So how will be the C2 in this molecule? So see, we need to pass a C2 axis like this direction. I will just pause for say some minute. So hope now I'm audible, right? So you can see here. Wait a minute, sorry. Now you can see the C2 axis. How this C2 axis? It's this molecule having the C2 axis, Q molecule, right? So the C2 axis, which axis passes to this carbon atom, the carbon atom, and the center of this ring. So we can rotate this molecule by 180 degree. Then we can able to visualize. See, these groups are same. This cis group, the group previously. After doing the C2 operation, how this molecule will look like, I will just show here that pre-draw the structure, so as you can uh, able to visualize it, right? The C2 axis passes through this one. So here we can see the atom, which is the second carbon atom. The similarly here also having second carbon atom. This carbon, the group which is cis, it's also having the cis group. And with the help of this, if you pass the axis from this direction, so this one will be the C2 for this molecule, C2 axis for this molecule. So the so this one will be the it having the C2 axis and both having the same configuration. So these are the correct statements, right? So it having the C2 axis. So the correct statement is the second one. Now we'll take another example. The two compounds are given below, right? So from these two compounds, uh, we need to understand the relation between them. What is the relation between them? So what are the options? The options first one is they are the enantiomers. Uh, Second option is the homomers. Third option is the diastereomers. And the fourth option is the conformational isomer. So which is the correct statement from this one? So uh,
Confirmation isomers.
so to understand this one, we need to draw the molecule first in the boat form, right? So in whenever this such type of systems are there, we should always draw the molecule in the boat form, and then only we need to consider this one. So that first we'll draw a one ring of we'll let's check this X molecule first. See, here we have drawn the ring, the second ring. While drawing, I have keep in mind this methyl group and hydrogens are anti. So this bridging. So just small. The methyl group, which is upper side, and the hydrogen atom is the lower side, right? So this we think we need to consider this, since these are the anti. And now the addition to this adjacent carbon, there is a one keto group. So here will be the a keto group, right? So this one is the X molecule. Similarly, we'll draw the Y molecule, right? In this one, same. Hydrogen is up, methyl is down. So I will draw one ring. Let's say I will draw this first ring, and for this one, this methyl group is the downward. Hydrogen is the up, and methyl will be the down. Methyl down, hydrogen up. So, and it, for understanding, I will draw a second ring with the another color. So here will be the uh, I will draw the B ring first, since it's drawing the structure in the board form to understand what we are looking for. It's little difficult, right? So the B ring I will draw first, and then A ring. So for B ring, this methyl is down, the hydrogen is here will be the keto group, right? And here will be another ring. The hydrogen is upper side. So I will just draw a little bigger size this ring. Both rings should be the equivalent of, right, like this one. So we need to consider relation between these two molecules. See, so for enantiomer, what is the condition for the enantiomer? They should be the mirror images of each other. The methyl group is lower side. And the methyl group should be the lower right, as here they have given by the dotted arrow. So dotted line. So I have written this methyl group in lower side. So here you can see for enantiomer, they should be the mirror images of each other. So whether these are the mirror images of each other or not, so that we need to check. Correct. So if you consider a mirror here, right, whether they really are mirror images of each other? No. because see here we can check methyl is up here, methyl is downside, and the group that is carbonyl group and the methyl group at this in these two structures, the hydrogen here, uh, here is a down, here is the hydrogen is upside, right? So we are not able to find out any mirror plane in this one. So these are obviously not a mirror images. Whether they are diastereomers of each other or conformational isomers or homomers, these two, three things we need to understand. See, if you rotate this molecule, the same molecule, to visualize for our visualization, we can able to identify these are the homos. I mean, these are the same molecules, right? We need to flip a ring and then check this one. So for this one, we need to understand describe the 3D model. So for that one, I will just utilize some software because it's sometimes it's getting difficult to understand the structures of the molecule by a simple see. What is this? I'll draw this with the ChemDraw. This is the ChemDraw software is freely available for academic use. So you can also install in your system whenever where possible to install. If you need this access of this ChemDraw, I will share a link in the YouTube video link, right? That one I will add in the session so as you can also download and utilize this ChemDraw software. Uh, it doesn't have any it's pirated version, so no need to use any serial and all. So you can able to install in your system. So this is the molecule, and I will just draw it in the ChemDraw. So this one is the ChemDraw software, and here we can see the methyl here attached in the first structure. Here is the methyl group attached. I will draw here methyl. Here hydrogen is attached, and the carbonyl group attached to this pole. Right. So this is the structure. We'll do a cleanup structure. So this one is the structure. Uh, we'll write it as a PQ view. Uh, we'll see the 3D model. Uh, see, here we can able to see a 3D model, right? I will try to make it full screen. Huh. So here you can visualize this molecule. I want to rotate this molecule. See, here only I think it's not possible to zoom this one. So here only you can see. I will just keep the structure, so whatever the written there. See, here you can see the boats, right? The two boats which are present here for this X molecule. The methyl group is upper side and the carbonyl group is there. So here you can see the carbonyl group is attached at this position, right? And the methyl group is upper side. So this one will be the right. This one will be the X structure. See, I will take a snip of this one. So this is possible in the for X structure, right? So I will keep it for our here. Now we will draw the Y structure and we will see whether same structure is possible for this Y also or not. See what is difference in the Y. So I will draw a Y molecule. This one like this. Sorry. So like this, there is one chair. Another chair is here one bone. There another bone. Chair should look like chair. So to understanding stereochemistry in the two dimension is little difficult, I understand. So I'm trying to put in the three dimension. I'm trying to visualize you so as you can able to solve the problems, right? So like this there is structure. Here is the methyl group, here it is attached. So here is the hydrogen atom is attached there, and where methyl group, the carbonyl group is here and methyl group is here lower side, right? This one is the now this structure we will see with the Chem3D. So this one is will be deleted, and this one is the Y structure. Now we will check whether for this Y molecule the similar structure is possible or not. So view 3D C. So this one is the molecule, right? In this one, methyl and hydrogen are opposite to each other. So here, uh, so Gaurav, do you have any question?
No, sir.
Okay, if not, then we'll just continue, right? So the same molecule, we have just written in Camera, and we are checking, we are seeing it on the with the help of this 3D model. So with the help of C, these are the two rings, six-member ring. The methyl group attached lower side and the hydrogen are opposite to that one. This hydrogen opposite, right? So we can see this molecule right now, correct? So this
Yes.
one is the Y molecule, and see this previously we have pasted structure for the X molecule. So with this molecule, we are trying to analyze whether these are the same or not. So you can see here, right now, let's see, right? So you can able to see the similar kind of structure we have also seen for this previous molecule also, right? Like this. Hmm. See, like this structure. Yes, right now you can see the structure. The similar structure is possible for the previous molecule also. I will take a snip of this one, snip, and oh sorry, and paste on the same page. So let's compare, right? So this is the structure of the Y molecule, and this one is the structure of X molecule. See, all are looks. These are the same one, same molecule looks exactly same. So these are the homomers of each other, right? Now, uh, for which of the following compound the value for symmetry sigma is same as that of the order H? So there are they have given the four different uh, structures, and we need to identify the symmetry number is same as H. What is H? These are the order of the point group. So we need to identify the which point group it belongs to, and then we can compare the symmetry. Also need to identify the symmetry number. So I have draw. We'll go little fast for this molecule since we have already seen this one in the many times in some similar structure. So twist boat. See, these are the twist boat, and for this twist boat, whether this molecule belongs to this molecule belong to the D2, right? Similarly, trans-decalin system. This is the trans-decalin system. So trans-decalin system, this molecule belong to C2H. Uh, nitrosyl chloride. This nitrosyl chloride having the only one plane, so this molecule belong to the CS point group. And the staggered conformation of the ferrocene. The ferrocene means the 5-member ring, uh, two 5-member ring attached to the sorry, iron atom Fe. So these are the four molecules, and this ferrocene staggered conformation, this molecule belong to D5H. Since the it's just a trick when the molecule having the belong to Cn or Dn, then the molecule belong to this molecule point to belong to the D2. It having the C2H. So when it belongs to D2, matlab Dn point group, then this having the symmetry number. So this this thing we need to keep in mind. So we can easily solve the problem like this. Since we don't need to check each and every molecule whether it's having how many CN or DN axis. So we can easily, if we keep this thing in mind, then we can able to easily just we need to check this molecule belong to which point group, and we need to just identify point groups, and then we can use this one. So this molecule belongs to DN point group. So the symmetry number for DN always equal to the order of this one. Similar cases for the CN also. The another question is the consider the following molecule and identify the correct statement, right? So this molecule you need to consider and identify the correct statement. First one is the molecule belong to T point group and order is 12. The molecule belong to C4 point group and the symmetry number is equal to 4. Third option is the molecule belongs to D2 point group and order is equal to 4. D option, the molecule belongs to S4. Molecule belongs to S4 and symmetry number equal to 2. So we need to identify which statement is the correct statement for this molecule, right? So in this one, firstly we need to draw a structure and visualize the whatever the possible axis, whatever the possible element of symmetries are present in this molecule. So let's draw the molecule. So I have previously drawn this molecule. So as you can save your time. So this one is the structure. So and we need to understand what are the possible symmetry elements that are present in this molecule. See here this configuration is R. This configuration is R. The group having the S configuration, the group having the S configuration, and the absolute configuration do not change with do not changes with the rotation, changes due to rotation. And if you rotate the molecule, then the configuration remains same. So it having the C2 axis. Other axes are not possible for this molecule, and it doesn't have having the any plane, since it's three rings are fused to each other. In the 3D we can visualize, but right now I will show the molecule in the 3 dimension in the on our next session. So as you guys can easily visualize this molecule also. I will use some Gaussian software, Gauss view software, so as this molecule can easily visualize by you. You can easily visualize this molecule. So here you can see it's having the S4 axis. So C2 and S4 axis are there. The molecule having this was, so this one is the correct answer. The molecule belongs to the C4 point group and the symmetry order equal to 2, because it's having the two one is the C2 and one is the S4. So this option is the correct option. We'll take another example. So they have given some molecules, and from this one we need to understand from ABCD arrange according increasing order of the value of symmetry number. So in order we need to arrange this one in the order of symmetry numbers. I'll just drink water later. So the video was initially paused. So let's. So what the question is? We need to identify the symmetry number, and then we need to arrange it according to the decreasing order of the values of the number of symmetry, how many symmetry numbers are present in this molecule. So for this one, we initially need to identify this molecule belong to which point group. So here I have solved this here given. The first molecule is this one. So it's having the C2, it belong to the C2 point group. So we need to initially identify this molecule belong to which point group. So this molecule belong to the C2 point group. Why? It's having the, this molecule is, let's see here. Two methyl groups are attached, right? This CH3 and this CH3. Uh, if we pass the plane, so the pass the C2 axis, so it's having the C2 and a plane which is passes to the plane of this phenyl ring. That one is also a sigma V plane. Another sigma plane is the plane which is passing through the C2, but bisect this part will remain one side and this part will be remain another side. So this one is another also two plane. So identity sigma, sorry, identity present, the C2 present, and two sigma V are present. So this molecule belong to the C2 V point group, right? Similarly, we need to identify the second molecule where it belongs to. The second, this is for first one. So this second molecule belong. It's, you can see the. I'll just rub this first one. So it's the second molecule. Oh, sorry. You can see here methyl group attached, that is CH2, and ethyl group is attached, CH2, CH3. So where this molecule belongs to, let's see. It doesn't have any kind of C2 molecule because it's unsymmetrical, and it is not having any inversion center or any axis. But you can imagine here there is one plane, that is sigma V plane, which is possible. So this molecule having the only one identity, and one is the sigma V, sorry, sigma plane is possible. So this molecule belong to the CS point group since it's having only C sigma plane. This third molecule, you can see this third molecule is the, what molecule is the, I'll draw it here. One methyl is attached, another one methyl is also attached here. You can imagine here the C2 is there, right? The C2 is possible here. Uh, Similarly, this molecule, you can see here correlation. This molecule exactly symmetrically equivalent. Symmetry in terms of this having the C2 and 2 sigma, that is the plane which is passes to this plane of this molecule, and plane which is perpendicular to this and passes through like this. So this molecule, what are the elements possible? So for this molecule is the, for third molecule, identity 1 C2 and 2 sigmas, sigma V are possible for this molecule. So this molecule also belong to the C2 V point group. What is the next molecule? So this one. So let's see the similar molecule, which is like this one. So it's just one position away. So it's having the CS point group. This methyl are opposite to each other. So this molecule we need to draw. Let first draw this molecule. Methyl are opposite to each other, right? CH3, CH3. C. This molecule, for this one, we can also take the help of our pie chart, but with practice, we should able to solve this without chart as well. The chart which were earlier discussed. Here it is. Yeah, this chart. I will take this chart uh, near our problem. Yeah, here it is. Hmm, right. So we can take this molecule. here draw the CH3 and CH3, right? So we need to identify this molecule belong to which point group initially. So for that purpose, we will start here. This molecule is non-linear molecule. Does it have the two C2s, two or more C2s axis, two or more CN axis with n greater than 2? Right, it exactly having the two or more C2s. See, here is the one C2 axis which is passes through this center. So this after one integration, this molecule come here, this atom. So this molecule passes perpendicular to this one is the C2, like with the direction perpendicular to this plane of this slide, right? The another C2s are where this another C2s. Let's check this side. Here also one C2 possible. The C2 which is perpendicular, it will draw here like this C2, right? Right. This two C2. Here also one C2 is possible, right? So it having the two or more C2s. Does it have two or more CN with N greater than 2? No, it's not. C2s are there, but not any kind of C3, right? C3. So we'll go to here. We need to check the CN. Does it have the CN axis? Obviously, it is having the CN axis. Are the N C2s axis are perpendicular to the principal axis, right? This C2 axis, the one C2, suppose let's make as a prime, or let's draw with the different color. So this blue one is the, let's say, principal axis, and these are the C2s are possible, right? Here will be the C2. Perpendicular C2 is there. So we need to go, it's yes, here. So in there, is there any horizontal plane, right? To this C2, that is principal axis. Here is the C2, and to this horizontal plane is present, right? The plane which is passes through this entire molecule, right? The benzene carbon atom, phenyl carbon atom, as well as this carbon. So that one is the mirror plane. So it's having, right, it's having a horizontal plane. Since it's n is equal to what is the highest n? N is equal to highest possible n is the 2. So the molecule having D2, and horizontal plane is also there. So D2H, right? So the molecule belong to the D2H point group. Similarly, the another example, CH3 and CH2, CH3. So see, she doesn't have any kind of, oh yeah, this one molecule you need to consider, right? In this one, the C, although at first instant it doesn't look, it looks, it doesn't have any kind of, oh sorry, something happens with the, wait, I will just hold. Right, here we can consider uh, this hydrogen and this hydrogen are the above plane, and in downward plane there is a methyl group. Like this we can consider, right? So this methyl is below the plane. So we can see here one possible C2 is there. Similarly, there are two sigma V's are also possible, which is passes through the C2 axis. So this molecule belong to the C2 V point group. And accordingly, for C2V, there are two symmetry elements like this. These are the C2 V point group. So for C2V, the identity and C2. So the order symmetry number will be the 2 for C2V. Similarly, for CS point group, this one is the elements possible for CS point group identity. There is no n, so only one is possible. Similar for C2, already consider for CS1 design 2 for D2H. What are the D2H? D2H point group means it having the identity C2 n C2s which are n perpendicular C2s, right? As well as the sigma H. So these are the some point symmetry elements that are possible, and so this is the one. The C2 is 2 and n C2s. N is equal to 2 since 2 multiplied by 2 is equal to, this is the sorry 2. So in total there are four symmetry numbers are possible for D2H point group. Similarly for C2V point group there are two symmetry number. Symmetry number will be the 2. So the order will be, so which is the correct order? Here is the this one. So A, B, C, D, right? So highest is the E. E is having highest. Then C, E, A, C, E having equal, right? A equal to C equal to E, and which is greater than D and B. That is B and D equal to D. So the correct option here is the correct option. So here correct answer for this one is the. So you can check with this one. E is having the highest one. So here is the E. So here they have given A having no. From this one E is having highest, but E and F equal. Wrong. E having greater than A. A is having 2. E having highest, then A, C and E. Sorry, A, C and F. A, C, F. E is having highest, right? Then A, C, F equal, then B and D equal, right? So this one is the correct answer. Similarly, oh, sorry. I'll just yeah, it's working, right? So what the next question is the consider the following reaction, right? So this is the reaction given. Initially understand what is the process here. So 2K, K is the potassium. The potassium atom gives the one electron, right? One electron. To this ring. So the final product having the 2 anion charge, cyclooctadiene anion. Right, and it's having two electron extra, so they are revolving in this thing. So we need to identify most appropriate option, right, among this one. So the value of symmetry number sigma for the reactant A is 4 and the product is 8. In this option, they told for let's label this as a starting S and product P, right? So the symmetry order for reactant or product. Instead of starting, we will give reactant and product P. And what they have written, they have given order for reactant is 4 and product is S. To need to understand this question, we need to identify to which point group this molecule is belongs to, and then only we can able to understand. So first, what will be the 3D structure of this one? So we know the cyclooctadiene is the tub shape molecule. How this molecule looks like this here, here, right. This one is the cyclooctadiene molecule, and this molecule, the point group we need to identify for this molecule. So we'll just take a help of this flow chart. I will just delete all the previous. Right. So cyclooctadiene belong to which molecule we need to identify. Sorry, I will draw it in some center. Right, like this. This molecule will be in this way, right? Since it's a tub shape molecule. And what happened? Uh, so the question is the molecule having the symmetry number order. In short, we need a symmetry number for comparison. Symmetry number and order. So to get these numbers, we should know the molecule belong to which point group. So here we are understanding the things. Cyclooctadiene. So in this cyclooctadiene, whether it is a linear molecule or not. So we need to understand the cyclooctadiene belong to which point group. So it's a non-linear molecule, right? It's a non-linear molecule. And does it have a 2 or more NC2s? C. Does it have 2 or more N axis with N greater than C2? No, it doesn't have. Since it have C2 is there, but C3, C4, C5, no, it's not there. So it will not, will go like this. Does it have the CN axis? Right, yes, it has the C2 axis. So we'll go this direction. Is there any NC2s, perpendicular axis are present? C. Where is the C2? The C2 which is passes through this one, right? This one is the C2 and perpendicular C2s are not there. So no, we need to go like this. Is there in horizontal mirror plane? So this molecule is non-planar, so it's not having non-planar, and this one tub-like, so it doesn't have any mirror plane. So this molecule belong to the wait. What they have written? Are there any NC2 axis perpendicular to this present? C. This one is the C2 axis, and NC2s we need to understand. which is perpendicular to the C. Here in this direction, there is another one C2 is present, right? Uh, the axis passes through this one, right? Here, also here. So the C2 is present, perpendicular C2 axes are also present there. So this molecule having the perpendicular C2s, but it doesn't have any horizontal plane, right? So the molecule belongs to the, it having a vertical plane, right? Like this one vertical plane here also, the plane passes through these two molecules. This, like this, we can divide the molecule into side, right? Equal part. So this molecule belong to D and D point group. Now n is equal to 2 since its principal axis is 2. So D, D2, D point group. So cyclooctadiene molecule belong to D2D molecule. So it's belong to D2D. And where the product belongs to, see the product, it's two, when it having the 2 minus charge, this molecule becomes aromatic. So it is the planar one now. So this molecule is the planar one. Now we need to understand what is the point group of this product, right? So we'll go again back here. So we'll follow. See, when you follow the flow chart, then we can able to get up to molecule belong to which point group, right? So make habit, you can draw on your notebook uh, this table and make a practice. So as you can get habit with this table, right? Anion, since anion, because of two negative charge, this molecule become a planar one. So for that purpose, the starting and product, they are belong to two different point groups and planar. So to identify point group, we will go through the flow chart. It is non-linear one, and here does it have a two or more NC2 axes? Does it have two or more NC2 axes? But En should be greater than, two, two or more. It's having one axis, right? Not more. Let's move this anion since it's resonating structure now, and so because of this resonating structure, this molecule, they entirely planar and two negative charge belong to here. And the axis, I will just for understanding, I will just withdraw this negative charge. See, here is the principal axis is present, and since it's having 8 centers, so it's C8 is present here. But more than 2, no, it's having C8 and another are the C2s are there, right? We can imagine there are number of C2s present, uh, which is passes through 8 passes between the adjacent carbon atoms, right? Like this structure. So number of C2s are present from each and every between each and every adjacent atom. There are lot many C2s are present, but En is not greater than 2. So it will not go this direction, we will go to this direction. Now it having Cn axis, yes, obviously it's having Cn axis. Are there NC2 axis is perpendicular to the principal axis present? Since this principal axis is a C8. So we need to identify whether does it having the 8 C2, 8 perpendicular C2. 8 perpendicular C2 present or not? Yes, it is having 1, here 2, here 3, here 4, here 5, 6, like this, 7, 8, So n perpendicular C2s are present, right? So yes. Is there in horizontal plane present? See, these are principal axis and plane which is passes through this uh, 8 atoms is the horizontal plane. Yes, it is having horizontal plane. So this molecule belongs to the DNH point group. That is Dn is equal to 8. That is D8H point group. So this cycloroctadiene anion, that is a product. This molecule belongs to D8H. And in case of DHS8, so we can get the what is the order of this point group now? Order is equal to for D8, D is equal to order is equal to 8 multiplied by 2 multiplied by 2. So this is the formula professor already told, right? So whenever there is a D, saying then we need to uh, multiply it by 4. That is 2 or 2. That is multiply by 4. So order is equal to the 32. And in case of D2D point group, there is order is equal to the D2D. Since it's n is equal to 2, 2 multiplied by 4 is equal to order is equal to 8. So for this order is equal to 8. For the product, order is equal to 32. And what is the symmetry number for D2D point group? The symmetry number is the 4, and symmetry number denoted by sigma. And for D8H, symmetry number is the 16. Now we can able to understand which is the correct statement. So here it is given symmetry number for reactant is 4. This is incorrect statement. Second, given the value for order H of reactant is 8. This one is the correct one. And the for product is 32. Right. This one statement is correct. Third, the option given the order, the value of symmetry number for reactant and product is same. No, it's incorrect statement since the product reactant and the product belong to two different point groups. So the order uh, also it belongs to D2H and product belong to D8H. D2D and D8H. So the order with respect to order we have written here. So this one is the correct. Right. So these are the value, and so this option is also not same, wrong. This option is incorrect. What is the last option? The order of symmetry number H for product for reactant is 4. Wrong. This option is also a wrong option. So option B is the correct option. So here is one question. The correct statement about the following molecule is it belongs to axial chirality and it has the S configuration. So this question we need the option given. It belongs to axial chirality and it has the S configuration. C. The plane. What is the condition for axial chirality? The attaching group on the carbon atom should be different. So first condition is satisfied, right? Two different groups. Whether they are same from another different carbon for this and this are same, but it's not. It's since it's axial chirality, so this molecule is axial chiral one, right? This one is the axis of the chirality, and we need to understand its configuration. So we'll view the molecule. Let's view from this side. Let's view from this side. So how it will look like? Let's draw like this. C. Methoxy, this is above the plane. Sorry, COH above the plane. Sorry, and hydrogen is below the plane. And so since COH, according to CIP rule, it has 1 priority, hydrogen has 2 priority. And when you look from this side, how it will be? The COH will be on right side, CO2H, and hydrogen will be there. It's having 3, it's having 4, and so the configuration is 1, 2, 3. It's S configuration, right? So the option 1 is the correct option. The next question is we'll just identify a correct statement about the CAT conformation of phenyl hydrophenanthrin, right? So we first need to draw a structure of this phenyl hydrophenanthrin. Per hydrophenanthrin. So this is the structure of the per hydrophenanthrin, and we need to draw a CAT, means oh sorry, I should not put it like this, right? What they have given? Syn anti trans, right? So these two, this, so this relation we need to understand. Where this is the per hydrophenanthrin, and it's so they have given CAT. So here they have given syn. It should be a syn, means if it is the hydrogen attached here is on upper side, then hydrogen on attached here itself should be upper side, and these two should be a anti. So these two are syn, these two should be anti. For anti, this will hydrogen is up, indicate this should be a down, means here we will not not any, we have not done here bold, it means it's downward. And trans, hence this one is here, so here also we need to draw like this. So this one is the structure. This structure we need to draw in the board form. So always try to write a B ring first, and then A, and remaining 2 ring A and C. This one is the B ring. Here, see, this hydrogen and this hydrogen are up, so we should draw this hydrogen up, this hydrogen up, right? And here also this hydrogen, see, this side, here and here, this thing are attached here and here, so we need to give a labeling to this one. This one should be a up one, right? And the adjacent hydrogen should be a down, right? This hydrogen is the down, so hydrogen written like this. Now we'll draw another A and B ring. See, A ring should be here down, and it should be here down, like this. And here also remaining two, see, like this. Oh sorry, like this. So these are the structure, right? So we need to check which is the correct statement of this one. All 4 ring junction has H hydrogens are axial. See, All are axial. Hydrogen axial, hydrogen axial. This one axial. Oh, see, this one is not axial. So first option is the incorrect one. So this one is wrong one because this hydrogen is not a axial one, right? I'll draw here. All four ring junction hydrogens are axial. This incorrect statement. This one is this hydrogen is the equatorial. Second option is two rings junction hydrogen are axial and rest two are equatorial. C. Number three hydrogen are axial and one hydrogen equatorial. Right. So this second option is also a wrong option. What given third option is the one ring junction hydrogen is equatorial and rest three are axial. Yes, this option is the correct option. Last option they have given one of the ring junction hydrogen axial and rest three are equatorial. No, three are axial. So this one option is the also incorrect option. So the option number C, option C is the correct option. Another question given from the chirality, which statement is correct about the following molecule? Correct statement about the following molecule. C. A is axially chiral. Wrong. This one, we know these systems are the planarity due to the chiral plane, right? Planarity, chiral plane. So first option is the wrong option. I'll just make it small. The second option they have given, it has a planar chirality and its configuration is S. So planar chirality up to here is the correct one, but it having the S configuration. So its configuration is yes, that we need to check. Here is the pilot atom. Sorry, here is the this one is the pilot atom, right? So and numbering start from the carbon atom which adjacent to the pilot atom. So where will the numbering go? I'll just select it. Here is one. Here is two. Oh, sorry. Just getting one. Here is two, and which third priority will go? Here will be third priority. So it's up. It's clockwise, right? So its composition is R, small r, right? Small r or small like this also you can try. So it's so the correct option is this one. Sorry, this one is yes composition they have given. So this one is the wrong. It has axial chirality and its composition is R. But here, right here, here there is a trick. Since so here the question given the correct statement, correct conformation representation of the following molecule is right. Just so the given here seen we need to check the correct representation for this molecule. So this one is A ring, B and C. Here also in this one A, B, C. So these two hydrogens should be seen. Here is hydrogen up, right? In both are seen. Here in two junction hydrogen up, right? It's seen. Hydrogen up. Here also hydrogen up. This one also seen. Hydrogen up, hydrogen up. is also seen. Yeah, up to here it's correct. And so we'll directly draw the structure based on this. So first we'll draw a middle ring, right? As usual, B ring we'll draw first. So this one is the B ring, and here we can see uh, the hydrogen is up. Here also hydrogen is up. So how the B ring will be? A ring will be A ring like this will be like this, right? And how this C ring will be? For the C ring, see here this hydrogen not given. It means the hydrogens are downward, right? Here they have not given anything, means hydrogen are downward. So the hydrogens are downward. Here also hydrogen is downward, and the remaining will be ring will be. So this carbon will be like this, and remaining part of the chain, sorry, ring will be like this. So which is the correct one here? Can compare this A structure is correct one. So this wrong, since it having the C here, though they have not given a kept any between, right? So this one obviously by default is wrong structure. In this one also C, they are attached to just adjacent carbon, so it's wrong. In this one we can see hydrogen up, but here you can see hydrogen is the down. This hydrogen should be a down. Here also hydrogen should be a down, but you can see here when they have given hydrogen up, right? And here also up. So this one is the wrong structure. The CNT optically inactive. The anti per hydroanthracis optically inactive because first to solve this question, we first need to draw the structure of this one molecule. Per hydroanthracis is per hydroanthracis like this, and what they have given syn anti syn. Syn anti syn means this should be a syn, right? Means both should be on upper side. Syn here anti, it means here it should be a downside, but these two should be a syn, means like this should be a conformation. And when you draw the structure of this one, how it will be? Always draw a middle ring first. So this one is the middle ring, and you can see. I will just this one is the B ring, and here you can see hydrogen is up. So hydrogen is up. Here also hydrogen up. So remaining carbon will draw. Right here is this, and here you can see here hydrogens are down. So this hydrogen should be a down. This hydrogen should be a down. So the remaining carbon we should need to draw. So it should be up. Here it should be up. Right. So this one we have drawn. So optically inactive. Why it is optically inactive? When the when any molecule having a improper axis of symmetry element present, improper element of proper element of symmetry and improper element of symmetry, right? Means any kind of plane is present, then the molecule will be a optically inactive. Plane is present, then molecule molecule is optically inactive, or if any SN axis, improper axis of symmetry is present, then a molecule is optically inactive. Also, if there is any inversion center is present, then also molecule is optically inactive. If any of this present, then molecule is optically inactive. See, this molecule having a center of inversion. You can see here, it's having the center of inversion. Right. So, molecule is optically inactive. Right. The next question is the following are the planar molecule and absolute computation. So we need to draw the absolute computation. Here is the, I will draw here only 1, 2, 3. So it's having the S computation, and another having here in this direction 1, 2, 3. It is having R computation. Right. So which answer is correct? The option D is correct on having S computation, S and R of the planar count in A and B for the A and B ring respectively. So A ring having the S computation, B ring having the B ring having the R computation. Right. So these are the some questions that we have covered. And if you have any doubts, please message me or mail me or text me. I will definitely uh, covered in the next session, which is on the next Tuesday. So thank you very much. And please, if you have any doubt, just message me or add in the comment section, so we can discuss in the next upcoming video. Thank you so much.